Thanks for coming, everybody. We've got a double team of performances today. We've got Andy Wood starting us off from Mines, and then his co-headliner, Katie Van Werkhoven from RTI, with some guest appearances. So it's like a Super Bowl show that we never had. With that, I will pass it right over to Andy.
Certainly. Thanks for showing up to pay attention and listen to Katie and I. I'm going to start off talking about the hydrometeorological testbed, which is to some extent linked with other projects, and especially the evaluation project that Katie and Matt and others at RTI are leading. I do have some colleagues who work with me at School of Mines, Josh Sertovan, Terry Hogue, who's a co-PI on the testbed project, and there are a few other students as well who are kind of spinning up, Ethan, Richie, and Juliet. Let's see, I'm trying to advance my slide. Okay, I'm going to go through about some motivations on the testbed and then give an example of some of the testbed protocols that we're working on right now. But I think one of the important things to understand is why this project is important and needed. And there's a few major motivations that have stood out for me over time. And to be honest, like when the CIROH proposal was being put together and I talked to Steve Burian and others like Martin Clark, probably the core thing that I emphasize that CIROH would need to be successful would be some kind of testbed-like capability for all the research that's getting developed in CIROH and its connection to the National Water Center. So one of the major motivations is basically has been our inability to track progress over time. And let's see, still having trouble with these advancing. Sorry, I have to, advancing keys or not. There we go. And let me go back a bit because I think I just skipped past 2 slides. So one of the first motivations basically is the widespread lack of common and published measures of the current scale of our hydrologic forecast capabilities. We've been making forecasts through our operational agencies for many, many years. There are great access points for these forecasts, such as the AHAPS website with all the different points that are being forecast by the river forecast centers. Some of them, they're also related, derived sites, such as the Western Water Supply Forecast site. There's also the National Water Model access points for the WRF hydro-based prediction system. But if you get asked about the skill of the forecast, which I have been in previous years, such as to give a seminar to different agencies on how skillful our streamflow forecasts are, there's really no basis for which you can discuss that. There are quite a few kind of regionalized or short-term or kind of localized even forecast verification efforts that, some RFCs may be standing up. And certainly the National Water Modeling team has for many years been kind of benchmarking within their development cycles as they go from one version of WRF hydro to another version, and various other pieces get added in. But that's not a commonly accessible outcome from this work that you can find, where you could quickly go in and say, okay, well, at say day 3, our streamflow predictions in these kinds of watersheds, maybe it's snowy or maybe it's arid, have a error profile of a certain kind. And part of this comes from the fact that our semi-manual forecasting paradigm in the river forecast centers is irreproducible. It involves a human in the loop. It's not something that we can exactly hindcast over enough past forecasts to develop skill statistics. And in general, we don't practice routine long-term skill assessments that get released with every change in the modeling system. And this is actually a common issue around the world. It's not just the US in hydrology. It's, as I'll show, it's more common in weather forecasting. So this is a big problem. I'm still having trouble with this slide control. And one of the consequences of this problem for R2O is that it's very hard to actually tell if an individual study has contributed a marginal benefit compared to the current practice. You know, most forecast-oriented research activities end up in papers, and I've written a number of forecasting papers myself, and you get down to the final paragraph, and you usually write a sentence, something like, you know, this method could have great benefit for operational forecasting of some specific objective, but you really have not shown that in your paper. And part of the reason is you don't really know what the benchmark is. You don't have access to the skill or outcomes of the current forecasts over the same period of time you did your study. And you can't even really benchmark easily against all the other papers that are out there that might be showing similar advances unless you have a relationship with the PI and you can get their data. So this is a big problem, the lack of this standardization, the lack of these published measures. We got a lot of papers out there. We don't get a lot of advances from the papers into research practice. This is back to the point I skipped ahead to erroneously earlier, which is that we don't really have ability to track progress in our forecasting capabilities over time. We've done this for, you know, many decades for weather forecasting, which is by nature a kind of global activity. You run global NWP models. All the different centers have products that overlap each other. And so it's natural that they've come together with some sort of standards for intercomparing their own forecasts. And this is just an example of being able to track one particular statistic, the anomaly correlation coefficient of the 500 millibar geopotential height field in different parts of the world, like the Northern Hemisphere, Southern Hemisphere, at different lead times. And we can, because of the standardization and benchmarking, as they go through new generations of their forecasting systems, they can track how these skill scores are improving. And we just don't have anything even close to this in hydrology. We can't look back and say over the last 20 years how our forecasts have advanced. I mean, we can make arguments that they have advanced because we've improved components of them, like precipitation, or maybe the model has improved, or there's been a post-processing of some kind, or better flow networks. But those are all kind of stands to reason arguments versus actual skill verification. So does NOAA already have test beds? Yes, it has a lot of test beds, and that's kind of a testament to the value of a test bed. You can see if you go to the NOAA test beds website, there have been a number. Some are actually quite close to hydrology, but for the most part, they tend to focus on climate, weather, other kinds of modeling, coastal modeling, hurricane modeling, and there's a concept for the test bed that I think is these test beds that has been summarized in a nice paper by Marty Ralph, who formerly led the hydrometeorology test bed, that is relevant for CIROH too. It's this idea that you have a loop of testing new refinements and evaluating them, and this loop allows you to make decisions about whether something should be operationalized. One thing about these test beds is that even with the HMT, none of the test beds have centrally focused on hydrology and hydrologic forecasting. We have a hydrometeorology test bed, but not a hydrology prediction test bed or a streamflow prediction test bed. And this is definitely not to, and one other point, I guess, is that in some of the test beds, it is partly about benchmarking new methods and data sets and systems. And it's also almost sometimes more so about evaluating the weather forecast experience as they're exposed to the new tools and getting their feedback on how those new tools might fit into operations to gauge whether they're kind of ready for prime time, which is a little less quantitative, but still quite important. In the HMT, it focused probably mostly on precipitation and precipitation forecasting. There was other work that was hydrology related, or I mean, precipitation and precip forecasting is hydrology related. All of it's relevant. Some of it is actually getting to hydrologic quantities like snow and snow level radars, snow level forecasting. There's some soil moisture work as well. But in general, it's not tackling the entire problem of producing and benchmarking streamflow and hydrologic predictions. And these are just some examples of some of the studies that were undertaken by HMT. So still very valuable. I think we wouldn't be talking about ARs as much as we do now without the work of this particular testbed. But one thing to stress in sort of the back of my mind with the CIROH testbed is that hydrologic forecasting is a blend of really diverse components and methods and data. And so where it's important to forecast on precipitation or focus on precipitation, which is one of the main inputs and most important inputs for hydrology modeling, there are all these other methodological data and modeling pieces, methods like hydrologic data assimilation or model calibration, or how you use observations to turn them into forcings, what kind of interpolation methods and analysis methods can be used to produce the best distributed forcings for our models, forecast post-processing. How do you downscale weather predictions and climate predictions to the kind of local scales needed to drive models? There are also elements of integration with water systems. So you represent and develop your system to include human impairments and being able to handle that. And lastly, I think there's a really important element, which is informatics perspectives on the whole process. I've always said hydrologic forecasting is as much a geophysical problem as it is an informatics problem. And to make the best skillful forecast, you really need to have an understanding of where the signals are that can be harnessed to provide skill in predictions. And they might be in the inputs, the meteorology, they might be in the structure of the model, and they might be just in techniques like data assimilation. But being able to have a perspective which lets you know how much investment to put in each area to get a certain kind of forecast and improve it is really important, as well as just wiring everything that you have together. So this testbed, unfortunately, in the first round of projects with CIROH, I was awarded a project on a hydrologic prediction testbed along with Terry Hogue. And the major objectives are to try to build out a hydrology prediction focused activity. I want to stress, like in the last bullet, that it's not so much just an analysis system for a certain kind of forecast, but more of a program similar to the other NOAA testbed programs, maybe not as formalized because we're within CIROH, but hopefully we're starting to lay the foundations for something that could become a longer term hydrologic prediction testbed. And then this would be targeted toward distinct objectives like short to medium range river forecasts and subseasonal climate forecasts, and some of the subcomponents as well, like how well do we do snow water equivalent simulation or meteorological prediction. And then one of the key outcomes is providing these missing benchmarks for the hydrologic forecasting elements. So the scheme that we have come up with in the last couple of years has been to have a linkage with different project teams and with the RTI, which provide, and others that provide evaluation tools, as well as trying to understand how we can leverage some of the CIROH cyber infrastructure to help with running these different experiments that would fit within the testbed. I want to say more about those. The testbed itself is going to be organized or is being organized around experimental protocols. I think there's a lot of flexibility in this activity in terms of where things run, how they are, where they are evaluated, where certain data sets are hosted, what workflows are used. But the core, aside from that, the kind of core concept is standardization. So I want to show an example of a protocol that we've been working on. I think I just again maybe skipped a slide, or missed a slide. Anyway, this gives a sense of what is in a protocol. So this is an example. One of the first ones is already activity where there's a lot of benchmarking going on, as I'll show. It's focused on daily stream flow simulation and unimpaired catchments. The idea is that once you define this focus, then you can think about what observations you need to evaluate the techniques you're developing. One of the most important parts of it is the reference capability. So what are you comparing against? What is the current operational practice or the current CIROH best in class, or the current developmental next gen solution that you are going to evaluate your work against? Once those elements are defined, you define an experimental design. And that's something that every person participating in this protocol, in this experiment, will use so that the results will be intercomparable. For instance, like there's a spatial nature to it. You would need to define where you're doing the experiments. And, for this one, we've talked about a camel-like collection, large samples, hundreds of basins, or a subset of that, a certain evaluation period that's standardized, and then specific metrics of performance that are agreed upon ahead of time and these are not the only metrics that anybody could ever calculate, but they're the sort of core metrics that would be calculated to allow for this intercomparison. There's other considerations that should be noted for each entry into the, innovation, which I'll talk about next, references, and then a list of kind of metadata elements that you would want to define for each of the innovations being tested. And these kind of allow the tracking of different entries or contributions and comparison, and also sort of tagging within the evaluation system. Let's see. I mentioned the reference capabilities. This is just an example for the this streamflow fork simulation protocol. Obvious reference capability would be the National Water Model current version 3.0. The retrospective is available, but I think 3.1 is not yet available. And then another obvious reference point when it's ready would be the baseline of the next gen modeling configuration, such as CFE with the T-route and common forcings. And then in addition to this, the protocols or the experimental protocols will have innovations kind of characterized in a standard way, where for each new capability or alternative that's being tested, there'll be some kind of tracking of what is involved in it, the short description, and then all the metadata that I didn't include here just for space, but that identifies what is in that particular solution. And it could include details on training and the specific versions of models and other things like that, forcings that get used. So these are two examples. Like we could test out an alternative to the CFE and the NWM based on SUMA on the hydrofabric with MISRoute TDX routing. We could test out an LSTM, the initial full version, and I'm hoping that Jonathan Frame will have a part in developing with the next gen forcings on the same basin data set. And this particular protocol builds on an activity that's been underway for a number of years. Now, since the CAMELS data set came out, it was an early example of kind of benchmarking of river forecast system like SAC, SMA, and SNO-17 models against other alternatives. Across all the basins, you could track a skill score and compare the benefit of a different model version. This has been picked up heavily within the machine learning community and has been one of the key data sets involved in training and and testing all these innovations, which have been incredible in that part of the hydrologic modeling world. I would say that even though we're a long way toward getting some kind of standard comparisons, we're not quite there yet, because as you look at different research groups, they're using, for instance, different time periods for compiling the scores in their internal studies. Some might not use all the basins, some do use all the basins. There are different forcings that get used. And so even though it looks like it all fits on the same page, it's not quite consistent. So this is where the protocols will have a role in bringing that kind of standardization. So we really do know, if I do some work at mines, how it compares to work that Xiaopeng Shen has done at Penn State or that exists at the National Water Center right now, and so forth. So I'll just go through quickly the protocol development process within this testbed activity is first just identify an area in which multiple groups are working. That might be a good place to have a common experimental protocol. I mentioned this daily streamflow simulation. We've also started to talk about some others as well. Think about, for your project, whether that could fit. Is it a very narrow one-off project that doesn't compare to much else? Or is it one that a number of people are working on and you might want to compare with them, as well as an activity at the National Water Center? So then once that's identified, you get a small group to draft kind of the initial protocol following a standard template, and then circulate and vet it within the community more broadly, finalize it. And then there's, this is what Katie will talk about a bit, a process of kind of linking and tuning or linking it to the evaluation system that they're building. And so that's one option for people to be able to run standard evaluations on the outputs of their experiment. I just want to mention briefly that this drive toward greater standardization benchmark doesn't just exist within CIROH or this talk or other activities in National Water Center, but around the world in the forecasting community, especially as we're starting to get to global operational hydrology from a number of centers like Google and ECMWF and SMHI and others. There's this recognition that we do need to start to move toward this paradigm where we can track our progress and intercompare across centers across the world. And so one thing that's happened recently is standing up a new expert team on operational hydrologic prediction systems. This came about in part through discussions that I had with others at in the Standing Committee for System Modeling and Prediction starting last year. We recognize that there has been an expert team for the same thing for weather forecasting systems for a long time, but we don't really have anything for operational hydrology. And so this got started. It has a number of people from the US, including Angelica Gutierrez from NOAA or from GEO, and then Sujay, who some of you may know, Kumar from NASA, but it's still growing. Another activity is there has been a lot of work in the last couple of years on developing WMO standard guidelines for verification, and this report will be released after some final review in the next probably couple months. So I think the point of this is that what we do within CIROH, I think, has relevance to some of these broader initiatives in hydrology, even outside the US. So lastly, next steps, what are we doing with this? We're going to continue to try to establish outreach with different CIROH projects where we can build community protocols. Ideally, we sort of help facilitate, and then it becomes a self-led activity by the key teams working in a specialized area. So this really is a call for everyone on this webinar to think about whether they can or want to participate, and then to reach back out to us and we can talk about where to go next. I'd like to finalize initial protocols, strengthen the connection with the TEEHR and RTI's activities. Part of this is assembling all this reference and observational data that starts to define those standards of practice, and then standing up a website that can track our successes of different groups across CIROH. And that's all I have before hopefully handing it off to Matt and Katie.
Yes. I'm just going to continue and take questions at the end, I think.
Yeah, that's fine.
Okay.
I'll stop sharing.
The virtual baton pass.
Did it work?
Yep.
All right. Okay, so this is part 2, focusing on the evaluation project. We are a team at RTI of several folks, primarily myself, Matt Deno, who's going to chime in here in a couple slides, Sam Lamont, and some help from John Park, Scott Sheeter, and Serena Gilson more recently. And as you've just heard, collaborating very closely with Andy, and also the team, the infrastructure team at at Alabama, James Hogren, our pizza, and many others. I know there's names that I haven't mentioned here, but it's a big collaboration and hopefully going to become a bigger one as we get more community involvement. Andy touched on a lot of this, but why are we building a formal evaluation capability for CIROH? A big part of it is consistency, as he mentioned, not only in the consistency in the experiments that are being run, but also consistency in the metric calculations. If everyone's doing their own calculations, we don't necessarily have confidence in comparing the results as well, that there's not small differences, that they're being calculated exactly the same way by the same definition. We need robust, reliable software for evaluation that meets CIROH's needs. So runs where we need it to run, is portable, is well documented and maintained. We need a platform for community input around evaluation. So that'll be the testbed, as well as part of the TEEHR repository. We're going to set up discussion boards to exchange ideas related to the testbed, but also beyond. Part of our goal is to support evaluation needs within and beyond the testbed experiments. The methods will be community driven through those discussions and the protocol meetings. And we're also thinking of setting up a repository where we can collectively share snippets of code for graphics or other things related to evaluation that have not been yet been incorporated into any formal system, so that everyone benefits from the developments and ideas that the rest of the community has. And also, like I already said, we aim to support not only the more formal protocol evaluations that are linked directly to the testbed, but also to support exploratory evaluation. And you've probably heard us talk about this quite a bit already. We're building some, we're aiming to structure the back end of TEEHR, and you'll hear some more of this from Matt, in a way that will very easily support interactive evaluation. So with efficiency and a data structure that will make it easy to explore the data in more detail. So once you get protocol metrics, this is kind of the vision, that there'd be a place to launch the protocol evaluation, but then also launch TEEHR Hub, where you can dig into the results and look at the data in more detail to understand where maybe a decline in performance is coming from or something unexpected is coming from. That's the vision. And this is not a simple thing. I think this goes without saying, kind of also thinking of that diagram that Andy showed, all the components of the forecast process. There's a lot of variables, data types, time horizons of interest. We need to handle historical simulations, as well as forecasts and sets of reforecasts, ensemble forecasts at 1 to thousands of locations, many different use requirements, where this needs to run, what the comfort level of users is. A lot of different variability. So it leads to nearly an endless list of evaluation methods. If we were to all collectively chime in what metrics should be used, what graphics should be used, we'd have a really, really long list. And that's what we're hoping for, but we're going to need to prioritize what gets included on top of what's already there. And it has to be scalable, portable, and flexible, not both in terms of flexibility and usability. So people can install it locally, work with the code directly, use example notebooks, etc. Okay, so just setting the stage for, I'm going to kind of get to the whole overall structure of TEEHR and kind of where the protocols fit in. of the project overall. So the general evaluation process that we all use within our research is the idea is to compare to two or more data sets, typically a simulation to an observed and potentially a baseline as well. We need to organize and store that data in some standard formats so our code can read it, filter the data to locations of interest, maybe flow ranges of interest, whatever you're trying to isolate and evaluate, join the compared and the verifying and the evaluated data sets at the right time step, et cetera, calculate metrics and review the results. So that's the core process of evaluation. And that's at the core of the evaluation system here, the evaluation project. So this is just slightly altered. We've thrown APIs in there as part of the core functionality. But on top of this core functionality, which is the gray here reflects the elements that are part of the TEEHR Python package directly. So part of the code itself. And the green is elements that are part of the project, but not part of the Python package, sort of ancillary tools associated with it. Visualization is likely going to be half and half. Some will be within the code, some may be external visualization examples, notebooks, things. Our documentation will be fully within the project. We're hoping to get more community input, so that'll be part of the project, but also part of the testbed effort and many other efforts. And we'll talk more about how we're suggesting that might happen shortly. And then there's the data. So a big part of this and a big part of the challenge is where's the data going to go? Where is it going to be stored? What are the data sets? What are the formats? And again, a lot of this is to be determined. Some of the data sets may be, a lot of them may be in the cloud, maybe in HydroShare, maybe in AWS. Then there'll be project data that needs to be pulled in and incorporated into the evaluation. The data is going to need to be processed into the format that the data model that Matt will talk about that TEEHR will understand. And all of this can be run either locally or we're setting up a cloud-hosted environment where people can run TEEHR on TEEHR Hub. And then there comes the protocols. So the protocols, as Andy described, would be developed as part of the protocol meetings, that process that Andy described. And then we will, I think Andy referred to it as a schema. We'll be setting up a tool to directly read those protocols. So they read the metadata, the metrics, all the instructions that we need to set up and define in a very standardized way to tell TEEHR what to do, what metrics to calculate, what data sets to use, how to join them, how to filter them. All those instructions need to be interpreted from the protocol definitions. And then on top of all of this, to make it easier to use, we'll likely build some apps, both on the front end to process data, some of the inputs, as well as on the back end to visualize and help draw conclusions about the results. So where we stand with all of this, I attempted to kind of roughly estimate where we stand with the orange coloring. We've really focused on the foundation, like this core functionality and the data structure behind this so that it is very efficient and flexible and meets the needs of that we've talked about previously, what we're referring to as the foundation. We've really tackled that in full. We've included some metrics, certainly not all that need to be in there. Some visualization has been tested, but not all. Some APIs, bits of the APIs, the documentation, some methods research and community input has started. Much more of that to come, hopefully. We've worked on some utilities. We've got utilities built to process the operational water model data, the retrospective data. All of that's been developed and is in use by a couple of projects. We have staged some common baseline data sets like those operational forecasts and retro data, the USGS data, and our setup utilities to access them. And we're building on other tools too, like HydroTools that's already out there. Yeah, so it's kind of where we stand. Bits and pieces of a lot of these project pieces. We have not tackled the protocol schema yet until we have a protocol to work with. And yeah, so next steps will be more community input, filling out the metrics and the visualization methods, completing the documentation, and really working on this linkage with the testbed protocols. And I think that's where Matt's taking over.
Yep, sounds good. Thanks, Katie.
Yep.
Yeah, so I'm going to dive into, I'll try not to get too technical, but I'm going to dive into a little bit of the designing and building of the foundation that Katie just described, that, kind of included the collection of the data, the storing of the data, the querying, the filter, the data models, and all of that. And so, along with that, we had some objectives that we were trying to meet in order to sort of make it useful for the community. The first one was to have it be flexible enough to handle a wide range of use cases. So, not all of the studies or innovations are going to be the same. So we really aimed for flexibility, so that we would be able to use it for a retrospective analysis, or evaluating a bunch of forecasts, ensemble forecasts, as well as different variables, parameters. Just really tried to keep it very flexible. We also were aiming for efficiency. We're envisioning and finding also that not surprisingly, there's some very large data sets that we have to deal with when you start looking at CONUS scale simulations, forecasts that generate new data regularly, every day, every hour, every few hours, as well as reforecast. So the volume of data that we're going to need to be able to evaluate is very large, and so efficiency and scalability were very important. Sort of along those same lines, we wanted it to be efficient enough at getting the data out that it would allow exploration, so that you weren't, forced to say, put in a request for some information and then wait a long time to find out, what the result was. We were really going for interactive, which meant that, asking a question of the data, and getting the result back needed to be quick. And then lastly, we're aiming to have it be, and think we have made it easy to use, so that not only the people that wrote it can use it, but also it will be useful to the community as a tool set, so that researchers will be able to evaluate their own data with the tool set. Next slide, please. So what makes it flexible? There's a few things. I mean, and I think Katie maybe touched on this a little bit, but we did develop a data model that we to start an evaluation or to start investigating data. We're putting it into this format. There currently is just 4 tables. You can see them on the right there. There's time series, geometry, attributes, and a crosswalk table to kind of join time series that have dissimilar IDs. This data model could be expanded based on feedback from the community as we get going, but we've found so far that that we're able to meet most of the needs with this very simple data model. And we have allowance or a way of tracking simulations, forecasts, and ensembles without making the data model too complex. And so so simple 4-table data model. We also really aimed for having as few constraints as possible. So for example, it's variable agnostic. It doesn't really care what variable you're putting in there, as long as right now it's set up primarily for scalar time series, at some location. But beyond that, it's super flexible, different time steps, units, etc. With the requirement, though, that within a study or within a protocol, they need to be consistent, so that things can be compared and joined and related. I guess there's 2 more points, even though I only have 1 more bullet point. So the data model, it's a data model, not really a table. So It can be used for file-based storage, so it could be Parquet file, CSV, or as actual database tables. Again, making it super flexible depending on the volume of data and what type of analysis you're trying to do. And the last point that I want to make, but I don't have a bullet point for, is, you know, as far as flexibility, we also built a lot of flexibility into the way that metrics are calculated. So we have many, you know, we have lots of methods for filtering, sorting, merging. So for example, if you wanted metrics at each individual location, you could do that. But if you would rather look at some output based on which state it's in or which RFC it relates to, we have ways of sort of aggregating across lots of different fields and attributes to kind of allow slicing and dicing in lots of different ways. Next slide, please. So, you know, another one of the key points that I laid out initially was, you know, we were really aiming to make it efficient. And so there's two main components that we think really help us reach our efficiency objective as far as, you know, speed and ability to operate, and scalability, ability to operate on large amounts of data. And that's the, you know, we stand on the backs of giants, right? We built it on two really, really powerful pieces of software, mainly the Parquet file format and DuckDB. So Parquet is a column-oriented data file format that you know, it's designed to be efficient for storage and retrieval. So when you're dealing with lots and lots of data, it's important to, you know, have space to store that on a disk or in the cloud somewhere. And then you need to be able to rapidly get at that data. Parquet files are really great for that. And then DuckDB, which is it's an analytical database, so it's really designed for processing large amounts of data. Yeah, I won't get into more technical details of it, but yeah, it's very good at processing large amounts of data without a huge memory footprint. So, you know, essentially you can crunch through and aggregate and filter and sort pretty rapidly on really large data sets. Along the way, we looked at several different storage approaches, and we're really, you know, concerned about write speed. So how quickly can we get the data in? Query speed, you know, how quickly can you aggregate and get the information out to see it, as well as like on disk storage. So, you know, how much room is it going to take up? Some traditional databases, by the time you sort of expand your data and put all your indices on the database, really can take up, you know, many times the space on disk that it would if it was compressed. So we had all that in mind, and really kind of came to this, you know, Parquet and DuckDB really works well. So I'm not going to put out any official benchmarks here, but just as an example, on the right kind of bottom there, I outlined one of our recent evaluations we did. And, you know, so I guess just to give a sense, it was 3-year simulation or 2 3-year simulations, retrospectives, like around 7,400 USGS gauges. That results in about 350 million rows of joined data. And we're able to calculate the NSE, KGE, RMSE, and bias for each location and each like simulation or configuration. It took around 17 seconds. So we're pretty pleased with that. Especially NSE is a real kind of memory hog, requires multiple loops over the data to get to the answer. So yeah, I'll leave it at that for that. I think we're probably getting close on time. So yeah, thanks, Katie. So as far as what makes it easy to use, you know, I went over the data model. It's quite simple. It's easy to get data into. If you can write CSV files or work in pandas or something, you know, it's relatively easy to rename column headers and save your data to whatever format you need. Yeah, along with that, it plays well with pandas and Python. And then, yeah, we're building out standard functions and utilities. I think having the data in a common data model sort of helps support this idea of having functions and utilities and standardized methods to generate metrics or other things to have consistent results. And then, yeah, APIs, I won't touch on that really, but examples and documentation, we're very much working on that and trying to speed that along. Of course, it makes it much easier for folks to use if there are good examples and good documentation. And, really that's what we want. We want community engagement and folks to use it and give us feedback about what works, what doesn't, what needs improvement, ideas, so that we can, make something useful for everybody. Next slide, please. I think we've probably touched on a lot of this, so I'll just go pretty fast. This kind of ties in with what Andy was saying, and I think Katie touched on it a little bit. But this is just maybe another vision of how the Testbed and TEEHR may interact. As far as the Testbed, pushing protocol and study metadata over into TEEHR, data sets being stored in cloud storage, and then being able to be pulled into TEEHR from there, and then the metrics and that kind of information maybe going back towards the Testbed website. Very much a work in progress here. So yeah, don't read into it too much, but kind of as a concept. And then as Katie was saying, we sort of have this vision that, there would be the ability to launch into TEEHR where all the raw data would be, so that you could explore it if if there was interest or wanting to understand what's going on in more detail. I think we're coming up on time, so yeah.
All right, I'm going to wrap it up. Just reiterating, Andy already talked about the initial example. We're getting started with Penn State. It's really helping us think through kind of where the data needs to be, what data is needed, what are the workflows that need to be set up, and how that might work. And also just level of, user engagement and examples that we'll need to generate. We've been collaborating kind of all along the way with the team at UA, the infrastructure team, which is now the next gen data stream team. They've been super helpful in getting us going on AWS and just collaborating that. I think there's an effort going on to generate the next gen output in TEEHR format directly. So that'll facilitate evaluating examples that are generated with next gen in a box. And we'd also, in addition to, I think the meetings, the protocol meetings that Andy's talked about, we also want to just have conversations with projects that have evaluation needs, so we have a better understanding of the range of needs that we need to be considering in our development, maybe those that are ready to be part of a protocol, and as well like those that are not yet. So if that sounds like you, send us an email so we can just have a conversation to learn more about the functionality that would be important to include for your projects. And we're going to launch, as I mentioned already, discussions on the repo to share ideas about maybe graphical methods and metrics that should be included. Again, both those that are part of the protocols and others that would just be useful to be part of the system. So that will be coming. So stay tuned for that. And that's all we have. Join us. It'll be fun. Oh, I think we have. And there's our the repo. GitHub repo is there. The initial documentation site, which is just a skeleton so far, but it's there, and my email address and Matt's email address. So that's it, all that we have. And Zach, we can probably take some questions.
Yeah, who's got questions? Fred?
Thank you. I really enjoyed that. I really did. It was thought-provoking. I have two questions. Let me turn my camera on so I can, with reference to NextGen and the high-level design diagram of NextGen that OWP is, we communicate with Raytheon and with the CIROH community, that design envisions what we're calling an evaluation manager. And high-level next-gen design invokes the concept of separation concerns, where all the major components do one thing, do it well, and can be run and tested in a standalone mode. So that implies that there's an evaluation thing that can be run alone. The variety of the high-level design represents a calibration evaluation cycle that allows for calibration of a model based on evaluations in a loop, where computed metrics are used to estimate parameters by some scheme, or one-off evaluations where the evaluation metrics are returned to a user. As you know, Andy provided a list of metrics. That's the set. There might be a few that somebody wants to add for some reason, but it's largely known. You know, an evaluation code should be extensible. So if somebody had a new metric, you know, log base 2 times of Q or something, they could add that. In terms of data types, OWP is interested in evaluation of time series and gridded data. So this evaluation manager is envisioned to do both of those things. So one question is, OWP views the next-gen framework as the essential basis that forms, I think, of a test bed.
Mm-hmm.
And it requires models and modules tested. The only requirement is it requires that the things you're testing be BMI compatible, compliant. So it provides access to a consistent set of forcings, hydrofabric, and if we have this evaluation manager, a consistent way of evaluating things. So the first question is the next-gen framework a test bed in your mind?
In my mind, I feel like it's a structure that enables testing of certain things because of its flexibility, particularly with model formulations. But then I also think of it providing a number of baselines, and it might be that the structure that is run operationally is oriented around a particular hydrofabric and set of models and particular forcing. But then we also want to be able to test every possible angle of variation, whether it's a new forcing or a new hydrofabric or a new model component or a new forecast data set or a new data assimilation method. So I do think it provides sort of structures that help you with that can be used in the test bed to really facilitate experimentation. But then some of the experimentation, I think, will go beyond that. And I think in my first version of CIROH testbed, I wanted to allow for some flexibility where if somebody had not yet gone to the work to completely BMI their solution for a model, they could somehow still test it, you know, to even see if it was worth going through that effort, you know, or refining it further before they actually sat down and started BMI work. So it's a more sandboxy in that regard. Okay. And on the metrics really quickly, WMO has kind of a practice of requiring certain core things and then also listing other recommended things. And so it could be that we do something similar where there are certain core metrics that get decided. They used to call them mandatory, but they felt like that was too aggressive. So now it's just core. But you know, could be 8 or 10 things that absolutely people should do if they want to compare with what NextGen is doing. But you could also recommend a bunch of other useful types of metrics or evaluations that could be done optionally.
Okay. So back to your answer on the testbed question. The first part, I mean, nothing about NextGen fixes the hydrofabric. You could test the same model using 2 different hydrofabrics. I buy the answer that, you know, people that don't have a BMI compliant model can have a test bed, a test suite. I have a question for Katie I'll get to really quick. I've done some research recently. The IEEE and ISO, for instance, have not developed standards for time series data, but the spectrum of data types that we evaluate will be, they're pretty limited: regular, irregular, breakpoint, with or without gaps, etc. The geospatial analysis community dealt with the challenge of people developing one-off coordinate conversion routines that each came with their own limitations or bugs by developing GDAL, which is a Swiss Army knife of coordinate conversions. And they use the standard definition of different coordinate systems to do that. It's extensible, it's open source, it lives in a total quality improvement paradigm. Can't we do the same thing with an evaluation system? If we produce a definition, or if we propose a standard for different types of time series data, couldn't we develop a GDAL-like evaluation tool that will solve everybody's evaluation problems so everybody can stop developing their own method?
Mhm.
That's for Katie.
In theory, yeah, I think so. In practice, will that happen? I think there's a point we all discuss, I think, that if there's a standardized tool out there, it is, it's usable. Folks want to use something simple when they're kind of in an experimental stage, something, just generate some code, calculate a quick metric, and do something, on their own internally and build their own things. But until we have a tool that really can handle all the cases, if we can get there, then we could have one single tool. But so far, there's nothing that we have available that handles everything. So in theory, yeah, we could get there, but we need to get there.
Sounds like a good goal to me.
Sufficiently not answer your question.
Yeah, thanks.
I could see making a tool that handles 80% of the things people want to do, and it would be like one of those common Python or R packages that people download to do verification or some particular thing. And that, if you design it right, I think it could get a lot of traction. I do wonder, there's this, and you touched on it, Fred, this idea of standardization of things like variable names and formats. That's a question for me, for Matt, on his data table, whether you allow for different groups to possibly have a different name for a variable or convention, like, is there that translation into kind of standard ontology of what particular variables are or measurements are?
We don't have that translation built in right now right now it's flexible in that it will accept lots of options, but it does not translate between them. So they have to be consistent within a study or protocol or something that you want to compare to one another. I think there would be value in standardizing and then having that translation, the ability to translate from whatever your, say, model output was to something standard. But we don't currently have that, but I can certainly see the value in it.
Like if you write out 5 gigs of output, you don't want to rewrite it just to change the variable names so they could be used. Rather, you just want to tell somebody what each thing is that can be used in place, I guess. Right.
I mean, one benefit of like a Parquet file or something like that is that if it has its columnar, so if it does have, it's really not changing that much to go ahead and just change it to rename it. It doesn't actually change all of the data, but I still think the point is a good one.
And there's going to have to be a translation step. I guess if like the next gen data stream team is generating output in TEEHR format, but there has to be a standardized format that TEEHR can interact with and understand, and we have to get the baseline data, the observed data, the project data, the innovation data into that format. So if it's not generated in that format as output from the project work directly, which it would be the easiest thing to do, but that would require development changes in the code, probably on the modeling side. So there's kind of inevitable that there's going to be some translation step needed to get from a native data format into the TEEHR data model somewhere.
Can you put a link to a document or a website describing the tier data format, Katie?
Yes.
That'd be great.
Matt, you want to do
Yeah,
that?
I will do that. Yeah. I would just add, I think there's, there would be value in not having to put it in one format, and being able to just read it in whatever format it is. But I do think that, you run up against efficiency issues. And if you want fast access, then it can't just be in any format, or it will impact performance. So we, I guess thus far we've taken this approach of translating it so that we have fast access and can operate on it quickly. But of course, the downside to that is that now you have to translate it into that format, which I think there's a cost benefit question there. I guess everybody knows where we came down on it, but it's an open question still that is probably worth having more discussion about.
I think GDAL provides, again, a decent model because they can read multiple input file formats. They just have to be defined.
Yeah.
Yeah.
Okay. Thank you.
Right, I do want to be mindful of our speaker's time. I don't know if everyone has to go somewhere, or if you want to take one more question.
I don't have to know, but I would just say to encourage everyone to think about whether they want to weigh in on some of the protocols that are getting developed and propose new ones, and we can sit down and chat. There's a lot to do in that regard.
Well, thank you again, everybody, for speaking today. We love having a trifecta of brainiacs, and we'll see everyone next month. We would wish everyone a good spring break, whether it's next week or now or in 2 weeks. I know that's coming up for a lot of us. And as a reminder, all these recordings always end up on the CIROH YouTube channel, so share them with people that weren't here or watch them again